And there you go. You're good to go.
Did a bunch of PowerPoints, and I click on one here. This is more on content. He said that that would put counting down up there. This is one of 4 PowerPoints that we've got in this section here. And it is tangentially related to what Dave was just saying, that the political parties were partly personalities, but they were also partly geography. It was an urban versus a rural party. It was a trade versus self-sufficiency party. And the PowerPoints that I've got talk about that, but in a backhanded kind of way. Counting down is a look at what really caused the Whiskey Rebellion. And it had to do with the rural versus urban divide that was happening already at the time. Now, it's a key idea in economic geography. It's one of the geography glicks that I'm talking about. It's the relationship between distance and jobs. And it sounds a little bit abstract, which is why we sat down with a mathematician and tried to work out a step-by-step way of presenting this idea. It meets these glicks about a geographic view. It's an old economic model. I'm going through the PowerPoint relatively fast because you've got it up on screen for you to look at on the website, I mean. The basic question is, how do you decide what to do with your land if you're in a particular place there? What do you need to know? It's obviously important to know about the conditions that are there, you know, good soil, a creek, what kind of weather, and so on. Those facts are important, but that's not enough. You have to know how far you are away from your customers or the trade networks that you've got. In other words, it's that old idea about conditions and connections. And that's where this skill of counting down becomes important. Now, we use the term counting down rather than we're talking about graph interpretation, we're talking about mathematics. But that's in fact what we're doing. This is a cross-disciplinary activity which meets a number of the math glicks for the 8th grade too. So let's do a very simple thought experiment. And a caution right away. Don't try to memorize any of these numbers. They're up there to talk about the principle that's going on here. We pick numbers to make the math easy. So imagine that all of the land within 10 miles of a town is exactly the same. It's flat, good soil, nice weather, no lions running around to chew on you or whatever. What if you tried to grow corn here right after the revolution? At that time, customers were willing to pay about $90 for all the corn that came off of one field and filled one wagon. Seeds, tools, and all these other things would cost about $42, a little bit less than half, which leaves you a profit of $48 if you are right next to your customer. And $48 200 years ago was a lot of money. But if the customers are far away, you've got a problem. Corn is heavy. You don't just put a load of it on your backpack and walk to town. So if your customer is 1 mile away, your profit goes down from $48 to $40. So we're going to put a G up there, you know, for grain. It's worth $40 and 1 mile away. Now we can start counting down. What's the profit at 2 miles? Got to deduct another $8 here. And so that makes it 32. What's the profit at 3? You got to deduct a little bit more, 24. Let's keep counting down. And you find out that when you get out to 6 miles away, which is just about where it was back in the colonial days, you ran out of the ability to sell corn from your land. That is, you could produce it, but you couldn't get it to the customer in time. It's part of the reason why little towns are spaced about 12 miles apart throughout most of the eastern North America. Now, This is useful information, but the real value of the theory comes when we compare a couple different land uses. Milk, for example, important product, much more valuable than grain, but it takes a lot of labor to produce it. And the profit is $80 before transportation. But it's heavy, it's a liquid, it spoils. You need a very specialized and very fast wagon. Cost of transportation back in the colonial days was about $20 per mile, which meant that if you're 1 mile away, you're down from $80 to $60. We'll put an M on the graph. What's the profit 2 miles away? Count down 20. 3 miles away, count down 20 more. Now already you can see one very important geographic fact. All of this land was identical, but the people that are close to the market are going to make more money selling milk, and the people that are far away are going to make more money selling grain. If that makes sense, and I hope it does, because this is a very step-by-step mathematical problem, we can keep adding more land uses. And the PowerPoint does do that. It says beef production is hopeless if you're close to the market because the other things are more valuable. But by the time you get far away, like out at 7 or 8 miles away, beef turns out to be a good thing to produce because it can walk itself to market. And so the transportation costs are very cheap. The counting down is very cheap. So it becomes the most profitable use about 6, 7, 8 miles away, even though it's much less profitable than closer. This is the geographic principle. High value uses of land tend to push low value uses farther away. Now, when I taught this in New York, I would use New York examples. I would say, I would love to have a split level house with a garden next to it, right next to where I work in Manhattan. The only problem is the land there was so expensive that only Donald Trump could afford to build a high-rise building there, which in fact was exactly what was right next to where I worked, was a high-rise building. So we could keep adding information about all kinds of other products to this. Ask kids now in October, where do you think pumpkins are going to be grown? Knowing what you know about spoiling and heavy and labor and so on. Probably quite close to the market. Whiskey, however, is a strange product because it actually is a cornfield. The problem is it takes a whole lot of effort to turn corn into whiskey. And so the profit isn't very high when you're right next to the market. But it's really cheap. It's really light compared to a cornfield. So when you turn corn into whiskey, you've made it more expensive, but also much easier to transport. And the result is, and remember, we're choosing all these numbers to make the math easier. In the real world, all of these distances are different. They're usually a little bit greater. But the point is, distance is a huge influence in your decision about using your land. Transportation costs are different for different products. As a result, people often do different things even on the same kind of land that has the same conditions. The low value land, like whiskey and like cattle raising, gets pushed farther away. It's called geographic displacement. Here's the graph again. Can you see what people are likely to grow at different distances from town? Might be easier if we drew lines to summarize the data. Might be even easier if we got rid of the symbols. And what you can see is that You just have to look at what line's on top at each distance. This, by the way, is exactly why we wound up having a whiskey rebellion during the colonial era, and why we had early political parties partitioning themselves on the lines of distance. It's because the people that were living close to the markets were part of the trade networks and so on, were able to do a whole lot more different things with their land. But the people that lived way out in the country, the ones that had to raise something like beef or whiskey, something that was expensive to raise but easy to transport. And then along comes a Congress who doesn't understand that. And they say, we're going to put a tax on different liquids, and we're going to make it perfectly fair. We're going to tax every liquid equally. And the result was that that tax essentially wiped out the profit of the whiskey producers. And when their profit was wiped out, they said, this government isn't working for me. I'm going to protest about it. And the only way I know, the only thing that's actually even cheaper than whiskey, and that is sending my son as a soldier in. Anyway, if government officials are not aware of these basic geographic distances, they might think that a tax of just $2 on all liquid products is fair. That's an important root of the Whiskey Rebellion. It's a historic fact. So the next time you drive past a cornfield in Michigan, think, if we were just a little bit farther away from the big cities like New York or Chicago, like maybe we were in Kentucky, where the roads aren't so good. How about we just turn this corn into whiskey, which more or less is exactly what happened in early historic times. And that has kind of hung on to today. So that's that PowerPoint about the Whiskey Rebellion. It's saying, if you wanted a math lesson that talked about graphing, but it also made a geographic principle about making decisions about using land, and it tied in with the Whiskey Rebellion. In other words, if you need a big break from reading a lot of text in these early lessons here, then you might want to try this guy out. I know that I did when I was teaching in New York, and I know that for some bizarre reason, New York 8th graders got a big kick out of counting down and trying to figure out how far away could you be before you would go completely broke trying to do something. And with that, I'm going to leave it. I raced over the PowerPoint because you've got it up on the website. You can look at it in a little bit more detail. I wanted to focus on the big point, and that is it's a cross math lesson that meets a geography click and also talks about a historic event and puts a different light on it, that it's not just personalities, it's also geography, land use, and distance that helped shape some of the early political factions in this country. And when we talk about the Northwest Ordinance a little bit later on, that's going to come back as an even bigger principle about the frontier. So, Davey, you got it.